One day in the Teletubby land, all of the Teletubbies' toys disappeared, so they decided to go look for them. There are 6 different paths for each of their toys, and they had to find answers for 2 questions per path. Teletubby, say hello.
Uh-oh.
I'm going to find my purse, so I have to find the areas of triangles.
I'm going to find my hat, so I have to find the areas of circles.
I'm going to find my bowl and my umbrella, so I have to find the areas of rectangles and irregular shapes.
Paul needs a scooter, and Paul needs to find the areas of regular shapes.
The first path is finding the areas of rectangles. For the first question of finding the area of a square, use the formula A equals L times W, where L is the length and W is the width. Lala, what would be the area of the square with one side length of 3 centimeters?
A equals 3 times 3, so the area is 9 centimeters squared.
Good job. What is the length of the rectangle is 5 centimeters and the width is 2 centimeters?
Area would be 5 times 2, therefore 10 centimeters squared.
Well done. Now you can go and find your ball. Next is Dixie's turn to solve the areas of circles to find his hat. To find the areas of circles, you need the equation A equals pi r squared. So what would be the area of a circle with radius of 7 inches?
It would be area equals pi times 7 squared, so the answer is 49 pi inches squared.
Well done. How about finding the radius with a given area? If the area is 36 pi inches squared, what would the radius of the circle be?
If the area is 36 pi, so the radius squared is 36. Therefore, the radius is 6 inches.
You did it, Dipsy. You can have your hat now.
Thank you.
It is now Tinky Winky's turn to find the areas of triangles by using the formula A equals half BH, where B is the base and H is the height. But for equilateral triangles, you can use the formula A equals S squared times square root of 3 over 4. Now, if the base of the triangle is 5 centimeters and the height of the triangle is 2 centimeters, what would the area of this triangle be?
5 times 2 equals 10, and a half is 10 is 5. So is the area of this triangle 5 centimeters squared?
That's right. Now, if we know the base of a right triangle is 4 centimeters and height is 3 centimeters, what is the area of this right triangle?
3 times 4 is 12, and 12 divided by 2 is 6. Is the area of the right triangle 6 centimeters squared?
That's right. Now you can go get your purse. Poe, now it's your turn. You will be finding the areas of regular shapes. The formula is A equals half NSR, where N equals number of sides, S equals length of a side, R equals radius of an inscribed circle. The first question is, what is the area of a heptagon with length of a side of 2 centimeters and R of 4 centimeters?
Heptagon has 7 sides, so n equals 7. Therefore, area equals half times 7 times 2 times 4, which equals 28 centimeters squared, right?
Yes. Now the next question. What about the area of a nonagon with side length of 3 centimeters and radius of 1 centimeter?
That would be area equals half times 9 times 3 times 1, which is 13.5 centimeters squared.
Perfect. You can get your scooter now.
Yay, thank you.
It is now Lala's turn again to solve the areas of irregular shapes. To find the areas of irregular shapes, we need to divide the shapes into easier shapes, then add those small areas together to find the total area, which is the area of the irregular shape. Let's take a look at the example.
The shape looks like a cross. Can we separate it into 3 rectangles?
Yes, you can, and that is the first step.
Because the shapes now are all rectangles, we can just add the areas of the rectangles up. 2 times 5 equals 10, 7 times 3 equals 21, and 4 times 5 equals 20. 10 plus 20, 1 plus 20 equals 51. So the area of the cross shape is 51.
Well done, Lala. Here, you can have your umbrella now.
Yay!
Now, Teletubbies are hungry, so they have to find their porridge. To get their porridge, Tinky Winky, Dipsy, Poe, and Lala must find the area between 2 curves by integrating the difference between the top function and the bottom function from limits a to b. So if the equations of the functions are f of x equals negative x squared minus 6x minus 1 and f of x equals 0 bounded by the line x equals 0, what is the area between the 2 functions?
The lower limit is x equals 0 because the graph is bounded by the line x equals 0. To find the upper limit, I'll set negative x squared minus 6x minus 1 equal to 0. So the upper limit is x equals 5.8. Poe, what do you think we should do next?
Let's integrate the top function minus the bottom function. What is the integral of negative x squared minus 6x minus 1 minus 0 from 0 to 5.8?
According to my calculations, that would be 30.1.
So the area between the 2 curves is 30.1.
Good job. Now, what if the equations of the two functions are f of x equals 5 minus x squared and f of x equals x?
Oh, set 5 minus x squared equals to x to find the intersection. The intersections are x equals negative 2.79 and x equals 1.79. So the upper limit is 1.79 and the lower limit is negative 2.79.
And the integral is 5 minus x squared negative x dx from minus 2.79 to 1.79.
So the area is 8.25.
Awesome. Now you can have your porridge.
That was easy.